Hello everyone, welcome to the topic Relations and Functions. Here we discuss composition of functions, FOG, GOF and inverse of a function. Let f from x to y be an invertible function. Show that f has unique inverse. It is given that f from x to y is an invertible function. A function is invertible only if it is 1, 1 and on 2. So we can say this given function f is 1, 1 function and on 2 function. Now, what is an inverse? Inverse is a rule defined from y to x in such a way that a g defined from y to x such a way that GOF is identity function and FOG also is identity function. Such a g is called inverse. Since it is given the function is invertible, there is definitely a g from y to x satisfying these two conditions. But our task is to prove that there is only one inverse, unique inverse. Since it is given to be invertible, it has inverse, there is no doubt. But our task is to show that the inverse is unique. There is only one inverse. How to prove it? Let's go by contradiction method. If possible, let there be two inverses for this f, named G1 and G2. If possible, is it possible? Yet to be checked. If possible, let's assume there are two inverses, G1 and G2. Now, as G1 is the inverse of f, we can say FOG1 must be I. FOG1 must be I. For any inverse, FOG should be I. For G to be called inverse, FOG should be identity function. So FOG1 must be I, identity function. That means FOG1 of y element will be equal to y itself. Or in other words, f of G1y is equal to y. This is the definition of the composition O. So f of G1y is equal to y. Keep it here. Now let's think of the G2. As G2 is the inverse of f, according to our assumption, both are inverses. As G2 is the inverse of f, we can say FOG2 should also be identity, which means FOG2 of any element y should be equal to y itself. That means f of G2y is equal to y for every y of the set y. So we got two conditions. Let's take these two statements. F of G1y is y for every y of this set. F of G2y of y is y for every y of this set. Look at these two equations. RHS is the same. This is y, this is y. So we can say f of G1y equal to f of G2y. From equation 1 and 2, we can say f of G1y equal to f of G2y. Look, f of an element is equal to f of another element. What can we conclude from here? See, since the f is invertible function, f is 1, 1 function. And 1, 1 function's definitions say that whenever f of an element is equal to f of another element, those two elements must be equal. So, f of G1y equal to f of G2y should imply that this G1y and G2y should be equal. They are the x1 and x2 here. So, we get G1y equal to G2y for every y, because this equation is for every y, for every y. So G1y equal to G2y for every y. G1 of y equal to G2 of y for every element means This G1 and G2 are doing the same job. G1 of an element, whatever you calculate, that will be same as G2 of the same element means, what is the difference between these two functions? These two functions are equal. So, we started taking two possible, if possible, two G1 and G2 inverses we started with. And we landed up in the conclusion that the two inverses that we assumed as saying if possible, they should be the same only. Hence, we conclude that the inverse of f is unique. F has only one inverse, or f has unique inverse.